So the name of the game today is Experimentation. I bought a bunch of toys from Goodwill that we're going to try to have a look at and see if we can circuit bend. I wanted things that made noise. I wanted things that had their own internal speaker outside the box. I wanted things that were all battery powered so I wouldn't electrocute myself. And I also wanted things that were kind of big-ish, which means they'll probably be more to poke around with, and also cheap. I think these were all less than $1 a piece. My tools for today are very, very limited. I have 2 screwdrivers of different sizes, and then I have a whole stack of batteries, AA's, which I hope are the right ones. So let's start with this one. A couple things that I'm thinking about here as I work on this is I always find it's good practice to take the batteries out. I have a Furby that I circuit bent, and at the time I circuit bent it, someone told me make sure you always take the batteries out, because if you forget and leave them in, they have the possibility to leak and break. And sure enough, my circuit bent Furby is now broken because of that. So just good practice to if I'm not using it, I'm going to take it out. I have some circuit bent Game Boys, and I certainly make sure for those that I'm always taking things out. Another thing that I'm doing is I always have a place to put screws. Again, we're just working with 1 screw now, but as we get more and more screws, oh, this one actually has some batteries in it. They're mismatched, which is never a good sign, but I'm gonna put this one aside for the moment. All right, to our magic wand here. Worth mentioning if you're doing this is that I'm not doing is I often take a lot of photos of these things as I go along just to make sure I can get them back the way I want to. But since we are taking a video of this, or I should say I am taking a video of this, I'm being a little less serious about that. But again, good to take some documentation and something that you can go back to if you're having trouble getting things back together. All right. Okay, this is our LED with the mirrors. Since the power supply goes down there, we got wires that go down. All right, speaker. What is this? That must be... That's probably how it's detecting it's being shaken? Seems like it. That's very interesting. Boy, if I screw this up, that's a neat little device that might be worth stealing. Okay, that seems attached there somehow. Let's see if I can tease this one out. There we go. Oh, look at this. Beautiful resistors we can see. So I'm just touching it there. I haven't licked my finger or anything. We can hear the sound is getting higher. So what's happening is that somewhere around here is our clock resistor, right? The resistor that affects the timing of the clock. So by touching this, I'm creating a short circuit, right? The voltage is able to jump across my skin better than the resistor. And so that makes the clock go faster and hence makes the sound go faster. That's pretty neat. I think it's this guy here. It might be that guy there. Okay, that's pretty neat. Let's leave this as is for the moment. We know we have some potential to do stuff in here. While we're at it... Oh yeah, I better turn that off. Let's hop over to Whack-A-Mole. Okay, well, I'm sure as I take out these screws, I'll switch it to like fast motion on the camera or something. I'm gonna set these aside. These are my screws for the magic wand. I'm gonna get another thing to put these screws in just so I don't mix them up. Again, I'm sure you're far more clever than I am and you wouldn't make that mistake, but why take the risk? All right, speaker here. There's the interesting stuff. I took the batteries out of this. Let's put them back in real quick. Okay, there we are. The switch was here. Well, so there are two wires that go into the mole. I'm going to assume those are to light those LED hats. I think this must be how they're detecting the things going down, but I'm not completely sure I know how that's working at the moment. A couple things that, again, why photos are good. See, there are these indentations in the board and the different color wires that go through them. This will probably go back together best if I remember which wires are going through which. So I'd take a photo, I did my zoom in now so we can, okay, yes, thank you. So we can look at those. These are resistors here. These are surface mount resistors, right? So they're smaller. It does make it a little bit harder to clip alligator clips onto these, but we can still poke around with our hands. So again, we'll turn them on. There it is. Again, once again, I'm going to zoom out, sorry. But that was it there when I touched that area. I'm shorting that out. This could be particularly interesting because, again, there's lots of speech in this. There's a lot more variety of sounds in this than in our Tinkerbell wand here. Now, the difference is you control when things play on this, right? So I can wave this and know it's going to make a sound. This one, since it's a game, it's doing things on its own. Just poke around a little bit. See? All right. That's pretty neat. Maybe I'll grab some alligator clips and we'll just see. Okay, so this is a 1K resistor. That doesn't really matter so much, but I just want to poke around a little bit. So let's flip this to this resistor, test my theory that this is the clock. That one is not the clock. Oh, it was this one over here. So in addition to the clock resistor, I'm just poking around to see if I can short circuit anything. Ooh, that's nice. On the leg of that capacitor there. So, the goal might be, depending on what I want to do, I could take this chip out, reset it in something else, and do something different altogether. I kind of like this wand. I like how you wave it. It seems to work nicely. It might be neat if I can somehow add buttons to the wand itself. This will involve drilling. This will involve some either soldering or wire wrap, but there seems to be some potential here. Currently, no pun intended, I can only, oh gosh, I gotta remember to edit that out. I can only make this clock go faster, right? Because I can't increase the resistance by running other resistors in parallel. If I want to slow down the clock, which will lead to some of the most interesting effects, I need to cut out this resistor and replace it with something that has more resistance. So again, we'll think about what we want to do with that. Let's poke around a little bit in this friend here. So this one's a little bit harder. I'm pretty unsurprised by that. This board is far more complicated. Again, it's got the surface mount components, which are harder to get at. But also this board is doing a lot of things. It's got the whole game happening there. And so it's not just the sound. This wand, all it's doing is this triggers, I forgot to turn it off. This triggers a sound to happen. It's not that you hit a mole and it makes a sound. It does all sorts of things. A little bit more challenging, not impossible. But I'd need to spend a little bit more time than I want to in this introduction here. I'm going to leave it there for today. We'll think about what our plans are for this one. Probably the next step is at least to make sure we're clear on what the clock resistor is, cut it out. We'll replace it with a way that we can increase the resistance beyond that to slow things down. And then if we want it to be variable, maybe we want to put in a potentiometer, an LDR, but we'll dig into that more next time. Hi, this is Simon. Welcome to our second circuit bending video, where I'm going to dig a little bit more into this magic wand here. So, I don't have many new tools today than I did last time. I have my screwdrivers. I do have a pair of wire cutters. I also, around me, I have some resistors. I have some variable resistors, some pots. I have some thermistors and LDRs, and we have a few things that we can experiment with as we look at this and we decide what modifications we want to make. Let me be a little bit more clear about components. Again, I'm not an electrical engineer, but I do know how to recognize resistors. Why, when I was opening this up, I said, oh, look at those resistors. Especially these kinds of resistors are easy to spot, they're easy to read, unlike the surface mount resistors we saw in the whack-a-mole. I also talked about capacitors. Again, visually, I know that this is a capacitor and this is a capacitor. I have a guess that these two are transistors, but I'm not completely sure about that. The other thing I did last time was make a mental note of where wires that come off this board go. So for example, there are two wires here, and they go into the rod of the wand, so we know that the batteries are down there, and so we can guess that that's the power. This red and black wire are going to the LED. These two white wires are coming from whatever this trigger device is, and then these two yellow wires are going to our speaker up here. Last time, I identified this resistor as our clock resistor, and that was just through poking around in the sound. So let's turn this back on again, remind ourselves what it sounds like. There it is. Okay. So what I have here is a 10K resistor that's on two jumper cables. So then 10 kilo ohms, and I clip that on either side there. Whoops. Much, much faster. So what's happening is it's easier to go through this resistor than this resistor. So we're sort of bypassing, actually, you know, there's an equation for adding together two resistors. If I remind myself in the edit, I'll put that up on screen. But that's less important than the fact that, again, we have less resistance now along this part, and so less resistance, so the clock is going faster. Now, we can find out what the resistance of this resistor is based off of the colored lines. I have terrible eyes. I looked at this before the video, and I looked it up on a chart. I believe this is a 560K resistor. So 560 kilo ohms. Ohms is our unit for resistance. So if I've been using a 10K to bypass that, this is significantly less than 560, right? 10 is less than 560. And so we're able to go much faster. One of the things we talked about last time is I can't make this clock go any slower without increasing the resistance. And I can't increase the resistance by just running things in parallel. If we think about that for a second, the reason is if we put something next to it that has more resistance, the current will take the route through this 560K resistor, which is easier to pass through. So what I'm actually going to do is I'm just going to cut one leg of this resistor. And I'm going to try to leave enough on either side. Okay. If I turn this on now and I try to trigger it, nothing's happening. It's because I've just disconnected that clock resistor, which is necessary. Now, just to try something out, let's now clip our lead. Again, we've still got this 10K resistor. I left just enough of that leg to clip on there and to clip on here. Oh, come on, friend. It's hard to grab onto. Turn it back on. I don't know how good your musical memory is, but that's just slightly lower. I'm gonna zoom out a hair. So now let's think about this. We have our 560K resistor, but then in addition, because now they're no longer wired up in parallel next to each other, they're wired up in series. So now we have a resistance of 570. Okay, that's kind of neat. Let me reach over here though, and instead of using that resistor there, let's throw in a variable resistor, potentiometer. Clicking the yellow to the middle and the red to one of the edges. Okay, let's see how we do. It's hard to hold multiple things at once here. Okay, so let's think about what's happening there. Still, whoops, I've just knocked it off. But still, we have our 560K resistor here. And now this potentiometer that I've added, if I've been keeping things in the correct bags, this says this is a 500K. So that means this variable resistor, as I turn it, it can have as little as 560, again, the original resistor that I've knocked off again, and as much as 1060. Okay, so that's neat. So one thing that I could potentially do is maybe drill a hole in the back of this wand, have a knob that comes out of it, and then I would be able to shake the wand and it would make a note, and then as it made the sound, I could change the pitch. All right, let's say goodbye to this guy for a second. Now, it's all about resistance, so it doesn't really matter how I do that resistance. So this is a light-dependent resistor. So again, I'm trying my best not to knock that off. So I've clipped in this light-dependent resistor, just one clip on each leg. I'm gonna put my hand over it, so less light. Probably this at its maximum doesn't offer as much as 500 kilo ohms of resistance. I'm gonna reach over and grab another jumper cable here. I don't actually know off the top of my head how much resistance this LDR can offer. But again, it's being added to the 560 that I have clipped in there, but I can also take this, again, I'm clipping it into the green, and then green goes to another one, which then goes to our yellow. So now I've run these LDRs in a series. As it gets darker, more resistance, lower pitch. So that's kind of neat. The photoresistors are always fun, but I did like, I guess I did kind of like this knob idea. I mean, we could go even further. I have 1 mega ohm resistors here. I mean, if I'd like the low sound, I could just put in a, it doesn't have to be a variable resistor, just a resistor in there. Turn that all the way. It sounds remarkably normal that slow. One of the other things that I was thinking about were buttons. Because once this sound starts, maybe I want to have a little bit more control over this. So here's a button. This button is, it's not a toggle, right? It's not a switch that goes on and off. It's just letting the current through when I'm holding it down. So, you know, one of the things I'm thinking about here is this wire to the speaker. So we've got 2 of them there. Cut. So that's just cut there. I'm not sure this will be effective, but let's see if I can strip that and get down to something I can clip onto again. So just to clarify, this should be the normal circuit. The only thing I've done is I've cut this wire and then clipped that together with the green one, and then the resistor that I've cut is clipped together with the yellow. So this should be the original. Okay, so that's working. Let's get a jumper cable here. And now, what we'll do is we'll put our switch in there. What I've done is I've clipped the wires onto the switch. Now when I touch this, we can see that it's getting triggered, right? Because the LED is coming on. But now it's not going to the speaker because the switch is off. There it is. Don't want them touching there. Okay. I'm just going to zoom in on that switch. It's hard to see. This switch has 3 legs. The green jumper cable is on the middle leg, and the right one's on the side. So again, I wish I had an assistant here, but oh well. Okay. I'm going to reconnect the variable resistor. 1 mega ohm variable resistor. Yellow. Red. So what I'm doing here is I'm experimenting with different things. Again, I have some ideas about what I want to do. Hey, triggering when notes happen is good. Being able to have some control over the pitch is a good thing. And so I have those ideas in my head, but I'm just trying different things. That's a good thing about working with these jumper cables and the alligator clips is nothing here is permanent. Possibly next steps, if I make something that I like, is going to be to solder on these components. Or I could possibly use a wire wrap tool. And so that's a no solder solution. But for now, let's see how we do. Okay, let's turn that clock resistor to be really low. And so now remember, if I put this all back together in its original case, I won't be touching here, I'll be waving the wand. So now I have 3 sort of controls. I wave the wand, and then I can adjust the speed and pitch with this, and then I can do a sort of stuttering on effect with this. The other thing to think about is last time when I was poking around, I found some other places that produce some interesting sounds, some interesting glitchy sounds. I just sort of randomly connected a couple things on the board. We can fish around and refine those. If I were clever, I would have marked those with a Sharpie last time when I did that, but I guess I was distracted by all of those screws I had to do for the whack-a-mole. But maybe we'll poke around a little bit, see if we can find something fun. Just clip onto this, for example. I'm going to, for now, bypass this switch. So I'm just going to clip these together, and then maybe we'll turn this up to its regular. Well, no, let's keep it low for a second. That's interesting. There we go. There's something fun. Okay, so let's say I like that sound. What I could do, I'm going to use the same switch. Sorry, I've just run out of colors here. I'm just going to do a green one there. Boom. And hook that up there. See if we got this working. And so now I have a little glitch switch, which is an accidental rhyme, but absolutely what I would call this in a final project. So we can switch it to super slow. Okay, so unlike the clock resistor, I really don't have any idea what I'm doing. If I'm glancing through this, right? Okay, something is happening with shorting that clock resistor to the LED, but I have no idea why that makes it make this sound. But if we're looking to add controls to this instrument, this one seems really fun. So get another switch, and then I can do that stutter effect. I can have a button to trigger a glitch, and I can control the speed. Right now, this is just a mess on my table, but next I would think about how I want to put this back together. I've said before that I think I really do want to get this all back in the wand. There's space in here to drill some holes and put those buttons through. Drilling holes for these square switches. I might see if I have any some different switches I could put on. If I were industrious, I could maybe 3D print something to attach onto the one. Believe it or not, I have a whole spool of pink 3D printer PLA, so I could print something that I could attach on here. But I'm not sure that's entirely necessary. Again, I would want a more permanent solution than these alligator clips, so I'd start doing some wire wrapping and or soldering, and maybe that's what we'll get to in the next video. I'm gonna leave it here for now though. Have some fun, stay safe, only do battery-powered stuff, and feel free to share what you're working on. All right, welcome to our third video on circuit bending, where I'm gonna try to get this wand back together in a way that makes it feel like a complete instrument. There's nothing wrong with having an instrument that's a pile of wires on your desk. That is certainly also an aesthetic option, but I'm excited to try to get everything back in this case. Significantly today, I've got some new tools. I've got my drill, so I'm gonna try to put some holes into this star so we can put in our knobs. I also have my soldering iron. A couple updates since last video. One is that I've changed our glitch switch to this button here. I kind of like this button a little bit better. Again, still our potentiometer that affects the clock speed. I ended up taking out the button that bypassed the speaker. It didn't really seem all that fun when I started to play with it more. But what I did instead was I found another short on the board that's interesting, and I made a switch for that. So this isn't a button that is instantaneous. This turns on. And once again, I'm not really sure what's happening here. But it somehow wires this control to the speed. So I think I'm going to the clock resistor with this capacitor that's detecting this. But again, it's nice to have something that I can now toggle on and off. I can flick the switch and change that. So now all I need to do is recreate this inside the case, and I want to replace these wires that I have alligator clips for with something more permanent. Couple of things just that I want to point out that I'm thinking about. It looks like I have this beautiful spot in the middle to put things, but keep in mind my star wants to go right in the middle there. So really the only place that I have to put components are here, here, and here. So this point in the star has the speaker, this point has the sensor, and right here is where the circuit board is going to return to. One final thing that I also am going to try to do is I want to add, this is just a little RCA jack. RCA jacks can be used for a lot of things, but they can be used for audio. And I'm thinking about putting that, if I can, seeing if I can fit that one in here. And what that'll do is that'll give us a way to get audio out of this to play to an amplifier or something like that, which might make this a little bit more useful of an instrument for performance. Maybe I'll start by soldering wires to this button and then drilling a hole that I can mount it in there. One thing with these plastic toys is I find it's always a good idea to start with a smaller drill bit than you need and then work your way up. And that really prevents the plastic from cracking. If I were to start immediately with the large size that this seems to require, maybe this 7/32, that looks even a bit too small. I betcha I would just crack this plastic, so I'm going to start with something very small to begin with. If I were being especially careful, I might also do some measurements and really make sure I center these holes. So I don't want to put a hole in my bench here, so maybe I'll borrow this for a moment. All right, that's still working. What I'm gonna do next is I could go ahead and drill all of the holes and then solder everything up. But since I've got so many wires here, it feels like it's smarter to now do a little bit of soldering and then get these clips out of the way and then start working on getting the next component in, just to make sure that we're maintaining all of the connections that we have. Okay, I did a very bad job keeping track of my wires there, and I knocked some clips off, but I think I got it. Let's check our glitch switch. It's working. So we've cut down the number of wires we have here. Is next the pot, or this I feel a little bit more confident about. Let's do that. Okay. My toggle's working. But my glitch switch isn't right now, so let's see what we've done. Oh, what's happened is, this is from my LED here. It's gotten disconnected. But, as I mentioned, yeah, that just came right off. As I mentioned, I wanted to replace this LED, so let's just do that. Alright, I want to replace that with a blue one. So I guess what was holding this was glued in. That's a bit annoying. I'm gonna have to reattach that with glue. Okay, sirrah. Let's see if we've got our LED back. Hey, there we go. See if the glitch switch is working again. Oh, it isn't. That's surprising. Let's see what's wrong there. I mean, you know, we didn't know what was going on there, so it's possible that changing the resistor had an effect. Let's leave that be for the moment, and then let's focus on getting this potentiometer in, and then let's see if we can deal with that switch. There's all sorts of pink plastic debris all over my desk now. There we go. I actually have a knob I'm going to put over this, but it looks like I should get that screw in first. Okay. So something's happened to my glitch switch. I'm not completely sure what. I either wired it up wrong. I'm not sure I hate that though. Toggle. I think I'm okay with not troubleshooting my glitch switch. Call it laziness, but I'm okay with that. Alright, so now the last thing I want to try to do before I close it up is get in this audio out. So what I'm going to do now is I'm going to wire up this audio jack in parallel. Oh, I've pulled off this wire off the speaker too in my violent soldering. It's okay, we need to fix this anyway. Double check. So far, so good. Gently, ever so gently. All the wires getting inside. All right, let's try an etude. All right, so we'll leave it there. Give this a try and let me know what you come up with.